Good morning, everyone. So, we're starting our new unit on solutions, which is chapter 12 in our textbooks. I've shared some information with you via Google Classroom on it. So, I'm going to just do a little voiceover for you so that you have some information. So there's different types of mixtures. We have homogeneous and heterogeneous. Think homogeneous, think the same. Heterogeneous, think different. So homogeneous mixtures are mixtures of substances that they're going to kind of look the same throughout. So you might not even notice that it's a mixture. So we call homogeneous mixtures solutions, and those are any substances that are evenly dispersed throughout another substance. So it can be liquids, solids, gas. It can be all of those states. And then there's some reading that goes with it for you because there's different types of solutions. So an example of a solution would be like lemonade. That could be, but if it has pulp, then it's no longer a solution, and now it's going to go into the heterogeneous category. So heterogeneous, we think they look different throughout. We have our suspensions, our colloids. We experience the Tyndall effect. So suspensions. When I think of suspensions, I kind of think of like the antibiotics that they give little kids, like the pink stuff or like the amoxicillin. So what they do is they have the medicine in there and they put like water in there, like distilled water, and then they close and they shake it, shake it, shake it, shake it, and then the kid takes it. But then the parents are supposed to, like refrigerate things like that. And then when they get them out, it says on the label, hey, you need to go ahead and shake this up because what happens is the particles will separate, and then you might just either give them too much of a dose, too little of a dose. So that's just an example of suspensions. Colloids, so like small particles throughout the substance. So maybe you can't see it very well, but if you were to like use a flashlight through some of it, you would see scattering of light. So light would kind of like just disperse everywhere within it. So examples are like milk. So have you ever like put some milk accidentally in like your water? I know I've seen plenty of things at my house where my kids are like, hey, I'm going to mix this stuff just for fun. And they'll put milk in things like, like a glass of water, and then you just see it and you just kind of see it disperse throughout. But the more milk you add, the more kind of like scattering you would see if you have a flashlight. So that's just an example. So like paint is an example as well. All right, so solutions, we have a couple of terms, solute and solvent. Solute is the item that is dissolved. So for example, like salt. It is a substance that dissolves in something else. It's usually the one that's in the smaller quantity of your substances. And then we have our solvent. The solvent contains the solute, so it's the one that does the dissolving. So, for example, water. Water, you put salt inside the water, which is a solvent. It's a great universal solvent, and it will dissolve the solid salt. All right, so here we see examples. So 10 grams of sugar and 500 mLs of water. Also, you notice that 500 is bigger than our 10. Typically, we'll see that our solvent is going to have a larger quantity than our solute. So 10 grams of sugar, which is the solute, will dissolve in 500 mLs of water, which is our solvent. All right, moving into our next slide, we have concentrated versus dilute. Concentrated versus dilute. So notice how we have two different images with particles kind of like inside our liquid or solvent. And notice that the concentrated version, the concentrated picture has more particles floating about than our dilute substance. So I kind of think of this as like you have, I don't know, juice, and you like apple juice. You can have concentrated apple juice or you can have dilute apple juice. Like in the freezers where they have the juice in a cans, and then you open up the can and you put it in a container and then you add water. The reason you're adding water is so that you can dilute your juice. So the more solvent that you have, the more dilute your substance will become. All right. Here we see diluted versus concentrated substance. This kind of looks like it could be cranberry juice. So notice like maybe pure cranberry juice, and then you add a little bit more water, some more water, some more water, some more water, and it just starts to become more diluted. All right. So here's a question. So when sugar dissolves in hot coffee, what is the solute? I think solute is a substance that is being dissolved. All right, so we have sugar, we have hot coffee. Sugar is being dissolved in hot coffee, which is the solvent. So our answer should be sugar. 50 grams of oxygen is mixed with 120 grams of nitrogen. Neither of them changes phase. So which would be the solvent? So if they're both the same phase of matter, we're thinking solvent. We're thinking about which one is larger in quantity. So 50, 120, 120 is larger in quantity. So our answer should be nitrogen. 100 grams of silver mixed with 34 grams of zinc to make a silver alloy. Which metal is a solvent? Just like a quick thing, alloy is a mixture of metals. All right. Typically, we think metals when we just think of all the periodic table things, but we also have, steel, we have brass. Those are examples of alloys. So which metal is the solvent? Remember, think solvent. They're both metals. Think of the numbers. So our answer should be silver. Solid red pigment is added to water to make a paint. Which is the solvent? Remember, solvent is the thing that does the dissolving. So here we have a pigment, so kind of like a dye in a way. And we have our water, right? So like pigment color. What do we got? Water. Water is a universal solvent. All right. Which is the correct categorization of a solution? Solution. Solution is another name for homogeneous mixture. Which is not likely to be a solvent. So we have water, kerosene, dirt, mineral oil, nail polish remover. So solvent, which do you think will not be used as a solvent? So if I'm looking at these options, I'm like, all right, that's typically in liquid states, solid state, liquid state, liquid state. So our answer should be dirt. 14 karat gold is a mixture of gold, silver, and copper mixed at the atomic level. How would you categorize 14 karat gold? Let's see. So we said it's a mixture. It's a mixture of metals. So it's an alloy. Oh, did I? I'm sorry, that's not what I meant to do. But hey, that's perfect. Alloy. A mixture in which the particles exhibit the Tyndall effect and eventually can settle out, so like separate, is classified as a suspension because they are settling out. If it was a colloid, they would not settle out. Orange juice with pulp will be classified as heterogeneous mixture. Ooh, solubility curves. So this is a whole lot easier if I was in front of the class with you. Notice this. This is our here,